We need to open our this week homework, correct?
Yes.
For lesson 4. And it's about probability, discrete random variables. Okay, so let's start with the first question. And Jessica, can you read it, please?
Sure. In your own words, list the 3 rules of probability.
Mm-hmm.
So there's the no probability to be greater than 1 or less than 0. The probabilities of all possible events must add up to exactly 1. And the probability of an event not happening is equal to 1 minus the probability that it does happen.
Okay. I think that this is some way easy, okay?
Okay.
Okay. Now, for the second question, we have a problem. And Michelle, can you read it, please?
Yeah. One of the probabilities is missing from the table. What should that missing probability be? If the table is supposed to be a probability distribution, so I have 38.3% because, and which rule of probability is rule number 1? The sum must be 100%.
Correct. Okay. 38.3, correct. Great. Now, the third question, I will read it. Randomly select a student in the class according to the table. What is the probability of selecting a student that is from Washington or Oregon? So what I did was add the proportion of Washington and Oregon, 9.8 plus 6, and the result will be 15.8%.
Okay, that's what I got.
That's what I got.
Great. So we can go to the next one. And Jessica?
Okay. Randomly select a student in the class. According to the table, what is the probability of selecting a student that is not from Idaho? Which rule of probability helps you?
Mm-hmm.
So the probability is 78.1, and I just, what did I do? I think I just added it all together and then said, no.
Oh. It's rule number 3.
Yes. It's
Yes.
Yes, that's what I got. Rule number 3.
Okay, I'll go to number 5. Randomly select a student in the class according to the table. What is the probability of selecting a student that is not from Utah or California? And it's the same situation. 81.4 is what I've got.
Yeah. In terms of calculation, what I did is 1 minus and then parentheses, not for Utah. What I did is I sum the proportion of Utah and California, correct?
Yeah.
So
and then subtracted that from 1.
Yeah. So it's 1 minus 0.109 plus 0.077 because I took the percentage and I had it later in the result.
Okay.
But the result is 81.4%. So next one, I can read it. Randomly select a student in the class according to the table. What is the probability of selecting a student that is from Texas? because Texas is not on the list and it's part of the others, but we don't know what others are, or even if Texas are there, we don't have sufficient data to answer this question.
And that's what I got.
Agreed.
Okay. So we jump now to the McDonald's one. Jessica, can you go to question 7?
Use the information in the table above to determine the probability that McDonald's stock will go down by 10% over the next year. So for that one, I got 0.14%.
Mm-hmm.
And I believe I just did the same thing again by adding up the others and subtracting it from 1.
Uh-huh. Yes, that's it. Because we know that the sum of all the probabilities must be 1. That's rule number
1.
1.
8, I had a little trouble with initially.
I did.
So I had problems with 8 and 9, so I didn't do it.
I did 8, but I don't know. I'm not sure how they got the answer. I just looked at the answer she got this, and I couldn't work it backwards either. So using the information on the table, determine the probability that McDonald's stock will go up by less than 16% over the next year. And that answer is 0.46, but I don't know how they got that. I can't.
Okay.
Nope.
Yeah. And
So where are they getting that 0.46 from?
I review all my notes, and I review all the other documents, and I could not see anything to explain me this.
I couldn't either.
And I was doing exercise this morning. It was horrible because I unless I'm not seeing here something that is very logical, I don't understand. They have a similar exercise. I did it. An assignment with a dice with 8 numbers. I don't know if you already.
Yeah.
No.
Yes, I did the preparation with the 8-sided dice.
Yeah, and I understand the logic there.
Right.
When they say that calculate the probability of rolling a number greater than 5, so we only have 3 more options, and divided by the 8, that's the total number of possible outcomes. But in this case, the biggest problem that I found is the possible outcomes. I could not find in this with this data what are the outcomes. They only have percentage, and they are randomly. Even when I sum all the percentage, and we have a total of 40%, and it's strange. So I could not understand this exercise.
I had a hard time with 8 and 9 as well. I didn't.
Yeah, because 9 is the same as 8.
I can see 9 because it says, using the information in the table, determine the probability that McDonald's stock will go up by exactly 10%.
10.
No one can predict exactly how much it's going to go up, so that would be 0.
Just because they use the word exactly, that's how you knew?
That's how I came, yeah. I mean, because I looked at the answer, and then I thought, okay, that's it. They can't predict exactly 10%.
Okay, it makes sense. But what about the will go up by less than 16%? So I know that is something between 15 and 16%. We know that is something higher, but I could not find how they.
I didn't either. I don't know either.
So what do you think that we can do about this?
We can put on the discussion board for the class, ask if
That's
anyone else can figure out number 8 and how they got it, because we can't.
That's a good idea.
Okay. That's a good idea. Yes.
Okay, well, let's move on. We don't want to, if we can't, we're all lost on it. Let's not dwell on it.
The problem is that if you're going to have questions like this in the quiz,
Right, we're going to be in trouble.
Well, we can do
Yeah.
the quiz twice, so we can take it together, and if it causes trouble, then we can wait to do the quiz till we get answers
Okay.
for the discussion board. The second quiz.
so let's jump to the quiz and see. What is strange about this exercise is because I didn't find any references on the study that we did.
I know, that was,
It's strange. It seems that it's out of the the control of what we studied. I don't know.
right, everything was going really good until then.
So you guys want to start the quiz now?
Yeah, lesson 4, right?
Yes. Okay, let's see.
Oh man, I went in the homework quiz. Darn it. Oh my goodness. Go back.
Oh, I did the homework quiz. Shoot,
That's what I just did.
I did that last time. Oh.
I don't want to take it yet. Oh, well,
I
And
don't know
I
if-
took it last week and I missed the same 2 questions both times.
that's kind of fun. Okay, group meeting quiz. Let me click on that one.
No, sorry. Okay, now it's ready.
Okay. Completed, true.
True. True. Okay. Now we have information here. Let's see. Human blood can be classified into one of our basic types: O, A, B, and AB. The proportion of people in the population of the United States which each of these blood types is summarized in the following table. Okay. Okay. Now, the first question. The blood types and the proportion given in the table above define a probability distribution. Okay, true or false?
It equals 1, all those numbers, so I would say true.
Yes. Okay. I was doing the sum, but if you already do it,
got a 1.
did it. Okay. So it's true.
Okay.
Question 4. What is the probability that a randomly selected person in the United States has type O blood, rounded 2 decimals places?
Wouldn't it be 45%? How do we
Yes.
figure that?
It's the probability is the px. In this case, it's the p of O. The p of O, it's 0.45. For what I understand, it's
So just 45%, that would. Okay.
I don't know if you have to put percentage, the symbol.
I don't either. It says round to 2 decimal places. So,
Yeah.
well, how are you? What are your answers looking like?
45.00. I don't know.
That rounding to 2 decimals is throwing me off.
I know. That's why I'm just going to think about it for 1 second before I put that. Hmm. And it's not like 1
So-
divided by 0.45? No,
No, so
That's
if we
a
go back
good
to our
question.
homework,
because then that would be 2.22222.
if we go back to our homework, we were asking what was the probability. We were just adding up the percentages, you know, for the student population.
Yeah.
Yes.
So there wasn't, it's not 45.2, it's just 45.
Okay.
It makes sense. It makes sense.
But where does the decimal go? Is it 0.40, is it 0.45?
Because,
I would think it's 0.45.
0.45?
Yes. Because
Okay,
we're
so
not, if
not
it's 45, then we're still in a percentage, right? I think it's the same answer as it is up there.
okay. So it's
That's-
0.45.
Yeah.
Okay,
Let's try not to make this harder than it is, right?
probably.
Well, it seems too easy.
I know. I know.
Because in this case, because the numbers represent px, and if you represent the px is the probability already. So next one.
Okay. What is the probability that a randomly selected person will not have type O blood? So now we just add up everybody else.
And then subtract from 1, right?
So it's 1 minus the 0.45, correct? It's the blood.
Yeah. It's the same answer.
55,
Okay.
correct?
Yeah.
Because we need to take the whole bloods.
And add them up, and that got 55.
Yeah.
Okay.
Okay, next one. Maybe Jessica can help us.
Oh, sure. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
1 and
1/6.
6. So, but you gotta divide that because they want it in a decimal. So that's like 1.667.
1 divided by 6,
Yeah, 1. Yeah,
1.
0.1666.
It's just 2.
So we round that.
So 3 decimals, it's 0.16.
Still 1.66. So you got 0.166.
I don't know if you need to round the last one to 7.
Well, it says to 3 spots, and the 7 doesn't come into play till about number 8 or 9 spot. So I think we just stick with 6.
Okay.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dogs would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that dogs can detect bladder cancer.
Yeah.
So 22 times is 50%, correct?
Yeah.
No, it's not 50. It's almost.
But it says it is very unlikely that the dogs would do this well by random chance alone.
Yeah, that's throwing me off because it seems like 2 different things. It's just a 50-50 chance, it looks like, but then they're telling you. I don't know if it's a trick.
Well, it's more than a 50-50 chance because it's a 1 in 6 chance each time. So it's not like 1 is and 1 isn't. There's only 1 specimen of cancer, and all the 5 the others are not cancer. And the dogs are picking that 22 times out of the 54. So so it's not just like 1 or the other, so it's not a 50-50 chance.
It provides strong evidence.
So just because, for me, it says it's very unlikely that the dogs would do this well, that tells me that there's strong evidence.
Yeah.
So it's the first one?
I think. But I don't want to get in trouble if I'm wrong.
No, just explain me another again, your logic.
Okay, well, the question says it is very unlikely that the dogs would do this well by random chance alone. So random chance would be there's 6 bowls of urine, only 1 is cancerous. So every time they're doing it, they have a 1 in 6 chance of, or they have a 1 in, they have a 1 in 6 chance of picking the right one.
Correct.
So, and they've done that 22 times. They picked the right one out of those 6. That makes sense?
Yes. Well.
So are we okay with that answer? They proved me, talk me out of it?
What is the combined total of 54 trials?
Well, let's try.
So it's the total of experiments that they did? I think so.
Yeah, 54 is how many experiments they did.
So 22 in 54 is 40%.
Okay.
It is very unlikely that the dog would do this well by random chance alone. Yes, I understand what the logic, and it seems that 40 in 54, it provides strong evidence.
Okay.
I think. I don't know what is the pattern here, but okay. Okay, let's go to the next one.
Okay.
Michelle.
M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
So you guys would say 13%, right?
Right.
That's how you answered the other one.
Right. Is that
Are we going to respond 0.13?
Yeah, 0.13, right?
Yeah.
0.13?
Yeah.
Okay.
What what is the probability that a randomly selected candy is green? So now we have to add up and subtract on this one.
I got 0.16.
Okay. It's the number that to make one, correct?
Yeah. Add,
How much
add
it
them
is?
all up and then subtract it from 1. Add up all the information you have, then subtract that from 1 to get the missing number.
And how much it is?
I added it all up. I got 0.84, then I subtracted that from 1 and I got 0.16. Did you guys get that?
16?
0.6.
Yes.
Yep, that's what I got.
Okay.
Are you guys good with that answer?
Yep.
Okay, and then what is the probability that a randomly selected candy is not green?
So that'd be the 0.84, right?
Yeah, that's what I would think.
It's not green, it's yes. Wow.
Okay.
Again.
We ready?
So, yeah. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from CAPEX.com. The following summary statistics were calculated. So we have mean, standard deviation, variance, minimum. Okay. Half of the observations are less than or equal to what number?
It would be the median, right?
Half of the yes are less than or equal to what number?
So 24.
24.
Based on information on the table above, the top 25% of the students score above what number?
Would that be Q3?
Yeah,
One.
27.
That's what I
Yeah.
think.
Yes. The top is the third quarter, so 27, okay?
Okay.
Then which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur.
That's true.
Mm-hmm.
A probability is a number between 0 and 1.
True.
If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's false. There's no negatives,
Yeah.
right?
Right.
No.
Okay. And then the sum of the probabilities in any probability is 1. That's correct.
Okay.
So we're safe with the third one.
Yeah. Okay, we ready to submit? Do you want me to submit? This
Sure,
time?
go for it.
Oh, we missed one.
And that which
Hold on. We missed. Okay, if the dogs guess at random, question number 6, what is the probability they will correctly identify the dish containing the specimen? So maybe we should have rounded up to 1.67.
yes, I learned that when you have at the end numbers up than 5, you round it to the
Oh, that's right.
nearest one.
Sorry, I just thought I was thinking of the 7.
So then it's 0.1667 or
0.167 is going to be.
7.
okay. All right. Well, I'll see if that's correct.
I'm gonna have to write all these
Okay.
questions down.
Okay.
Let's see. No, that
But-
answer is not correct.
No?
Uh-oh.
0.167 is not correct.
So, in the dogs guess at random what is the probability that they will correctly identify the dish containing the specimen. Let's see again. With dogs and trained, the dogs were trained to lie down. 7 bowls.
Is it 7 bowls?
Yes, 7 bowls
Oh.
containing urine
Shoot.
were lined up.
Okay.
And then,
Oh,
we
and
did
then
the
it
math.
says 6,
How did we miss that?
6 of the
No.
7 bowls.
Oh, because 6 of the samples were from patients
Yeah.
who did not have. So
And
Oh.
1 from, okay,
No
so it's
mistake.
1 divided by 7. So it's 0.142. No, 1.43.
143.
Yeah, so 0.143.
Okay.
Let's see if we are now. Okay, let's. My computer today is very slow. Ah! No, no. Okay. Let's see. It was question 9, correct?
6.
6. Question 6. Yes. It is correct.
That was just
It's-
an oversight, right?
Yes. Okay. Great. So we need to review all the answers. It's not necessary.
No, hold on. I'm gonna make sure I get all my questions answered right before I let you go.
Okay.
Is true. 4 is 0.45. 5 is 0.55. 6 is 0.143.
Yes.
Okay. 7 is yes. 8.
It's interesting because again, there were no question similar that one of the homework.
I know. We should complain about that.
I'm going to write something on discussion board
Okay.
that's a good idea.
because I'm intrigued about this one.
Okay, I'm gonna hurry and just check my answers again. So I went really fast.
Okay.
Okay,
Correct?
you got it.
Wonderful.
All right.
So I think we are done for today.
Yep, I'll
Thanks,
We meet
guys.
see you
again
guys Friday morning,
next.
and I'll get this posted.
Okay.
So Ricardo,
you.
do you want
Yes.
to do it Friday morning and try again?
Yes, I will send this link to the both emails, okay?
Okay, thank you.
And I will try to see how to record these meetings.
Okay, sounds
No
good.
problem.
See you guys Friday morning.
Okay?
Thanks, guys.
Bye-bye.
Bye.
Bye.
Bye-bye.